Next up, broadcasting. We already talked about the broadcasts of learning. The learning is actually a very small amount. Okay? What happens is, I'll put my switches. If y'all go into the network neighborhood and you can see these servers listed, you might wonder, how did those servers get on my list? Okay. What happens is you can actually send out FF, If I send something to the destination address of all Fs, what does that make it? In binary? Is that all my octets? 1, 2, 3, 4. Oh, one more. This is all ones. If I send out a frame to all ones, this tells the switches to broadcast it anyway. Okay? And here's some of the things that get broadcast. Number one is the server. They send out things that basically say, I am here. Here are my services. So they'll tell you things like, I have these printers connected to me. I have these file shares connected. If you want to get on this whatever file share or network, connect to me. And servers are sending these out all the time. Okay? This is, I don't know, we'll just say every few seconds. The one that really kills you, though, is clients, servers, and routers. They send out a thing called, what is the MAC address of, we'll just put X IP address. Okay? We'll get more into IP address and how that works in a little while. But you guys know when you type something in like odu.edu, you don't actually connect. There's no word of that. You're connecting to an IP address. It's 128.82. It's funny, I was just looking this up, but I don't remember what it is. It's something. I'll just put questions. 128.82 something. But when your computer wants to connect to that, it has to know what the MAC address is. Okay? If we want to get to that server, that's layer 3, right? But in order to really get there, I need to know its MAC address, so it's layer 2, okay? So these kind of broadcasts happen all the time. They call this Address Resolution Protocol, ARP. ARP broadcasts all the time. If you plug your computer in and you plug in a thing that will give you like an Ethernet dump, everything that's happening on Ethernet, if you're connected to a switched network, you only are going to hear basically broadcasts, but you're going to hear a lot of them because it's all of these broadcasts. Who is this? Who is this? Who is this? Who is this? So those are all over the place. If you have too many broadcasts, you're going to have congestion. And the upper limit right now is about, I'll do my approximate sign, you don't want any more than about 500 hosts on a subnet. Okay, remember a subnet was all the stuff connected to a switch. Are we groovy with that? That's nice. I keep saying groovy. My older kid picked up saying excellent, and so he says excellent all the time. Would you stop saying that? You've already said that 20 times. I don't need to hear it again. So notice here I got 85. What do we add all these up? This is about 400. This is about as many as you want on a subnet at a time. Because over this, you're going to get, all those broadcasts start to take up all this uplink traffic and everything else, and eventually it's just too much. It makes a big mess. When we were on a hub network, just for comparison, about 100 hosts on a hub network was pretty bad. And once you got to about 200 hosts on a hub network, the network just didn't stay up. And it was the equivalent of, what are we doing here? Where's my little input queue one? Where's my hierarchy diagram? It was the equivalent of like this, right? With a hub network, all those broadcasts, all those people talking, only one person can talk at once. And so whenever they collided, so anytime two people talked at once, they both have to stop, and then they try to talk again. Those were fun times. Lots and lots of messed up stuff. So 500 hosts on a switched subnet. That's pretty much your maximum.